This video is to show how the GOM Scan 1 system can take a 3D scan of a small object. The GOM Scan 1 was created as a little brother system to the ATOS Q, which is GOM's flagship product. It is the absolute gold standard for 3D scanning precision, accuracy, and resolution. The GOM Scan 1 still has all of the same core technology as the ATOS Q in a smaller package, just scaled down a little bit at a much more affordable price point. So taking a look, I've got a system set up here. This is the GOM Scan 1 scanning head with the 200 MV measuring volume. That means it has a field of view roughly 200 millimeters on the target that I've got it pointed at. So the GOM Scan 1 comes in 100, 200, and 400 MV options. And if you needed much smaller parts or much larger parts, you could get a different one. If you needed multiple different size ranges, you can purchase more than one, and they would come as entirely different scanning heads that would come on and off the tripod as you needed to change tasks. I'm also using the GOM 350 rotation table. This is a motorized turntable that's going to spin the part for me and give me multiple positions on the same object without me needing to interact. If I didn't want to use that, the system also comes with a plate that I can put parts on. Either way, I'm using scanning targets to help the system understand how the part is moving with each scan and translate the data sets to each other. With the rotation table, I get some automation built in. With the plate, I would have to move it myself, but I would still get the same accuracy at the end of the day. So I'm going to tell the software using the workflow assistant that I want to scan a single part, and then I'm going to be using the rotation table. I'm going to adjust the number of spins on the rotation table down to 6 because this is a relatively simple part, and I think I can get 100% of the surface area with less positions. If the part was more complex, I might use more. I'm going to tell it the ambient temperature is about 20 C, and now the system is going to take its first image of the part. The system is going to show me what it gets, and I can take a moment to check and see if it's doing everything I want it to. I'm happy to see that the part fits nicely inside the field of view of the scanner, and that it's highlighting in red the correct part of the scan that I'm going to want deleted, in this case, just the turntable. If this wasn't correct, then I could optionally go in and manually tell it what I want it to delete, but I'm going to keep this because it looks good to me. So the GOM Scan 1 works pretty simply. The central lens is a projector that's putting out a series of patterns of structured light. It's called fringe projection. And then the two lenses on the outside are the left and right cameras. These are simple digital cameras that are taking two-dimensional photographs of the part with the light pattern projected on it, and the software is able to infer three-dimensional geometry. We're about done here. It's taking the last position, and you can see that it has moved these to each other in 3D space to match up correctly. And this first scan looks really good. Now I'm going to take the part and flip it over on its other side so I can take a second scan. And I'm going to use just a little bit of clay putty to stabilize the part because I don't want it to rock back and forth on a round surface. I'm going to tell the software that I'm scanning a second side, and I'm going to restart the same process, scanning with the rotation table. Once again, it's going to give me the first position, and I can take a look at it and see if it works for me. That looks good, so I'm going to kick it off to take another 5 positions. Now, it should be noted that if all I needed was geometry that I could pick up all from one position on the turntable, and I'm not going to need to flip the part over onto another side, there would then be no need to put targets on the part itself. If I want to be able to pick it up, flip it over, and get 100% of the part, then I'm really just placing a minimum of 3 stickers. I think I put 5 or 6 on it in this case, and I'm placing them strategically around the perimeter of the part in areas that are going to be picked up in both orientations. So this is finished, and I can tell it that I want to transform the second scan onto the first one. The software calculates this automatically off of the targets. We should say that it is possible to reorient scans by best fit of the geometry, but the targets are more accurate and provide some really useful error checking features in the software. Finally, I'm going to tell it that I want to finish scanning and polygonize the data. This is going to take our point cloud data that we've collected and mesh it into a mesh object, which is, if you've ever done 3D printing, an STL file is the most common format people use for this. It's a solid object made up of a very, very large number of very, very small, flat, triangular surfaces, and I can use that for any number of applications going forward if I need to. Okay, the process is complete, and we can take a look at our final result. This looks really nice, and I'm seeing both some really crisp detail on the part, including some defects like where a weld probably took place, seeing the text very clearly. We can take a look at the mesh by displaying this triangular structure like so. And at this point, I can either bring in a CAD model that represents the intended geometry of this part into GOM Inspect and use it to do a QA workflow, or I can export the mesh out of this software into a different piece of software to use it for reverse engineering or potentially any other application that may be needed. I hope that this was helpful. Please reach out to Trimax Solutions with any questions that you have about the GOM Scan 1 or any other 3D scanning product. Thank you very much.